Hello everyone, I am Naveen G. As a part of human factors in AI assignment, let us discuss how to design user experience and evaluate the privacy and ethical implications of ML based product. We'll walk through below points in this presentation. The project background will provide a brief background of the project and the problem statement. Then move on to task analysis. We'll analyze the step-by-step details of the existing user task flow. Then we will move on to user experience design, followed by the privacy considerations and ethical considerations. Let's start with the project background. The problem we are considering here is predict the maintenance schedule for motors. Motors are commonly used in every industry and are critical elements of industrial production. Failure of motors affects the production, which is loss to business. Acting after the motor failure is not an option. Preventive maintenance is the traditional method where motor health is monitored periodically and maintenance repairs are undertaken to avoid the failures. The failures within the monitoring period go unmonitored and contribute to the costly repairs and loss to the business. Increasing the manual monitoring frequency is increasing the cost. Also, the manual analysis of data is not providing the detailed insight into the possible future issues. We are moving towards the predictive maintenance with our ML-based solution with the following metrics. Outcome metric of 10% reduction in the motor maintenance cost and output metric of R square, that is coefficient of determination, with a value of 0.9. To understand the problem in detail, let us do the task analysis. Flow diagram here depicts the steps involved in the current process. There are multiple sensors which measure the parameters such as voltage, current, vibration, insulation, etc. Then data is logged locally till the point it is collected by the user. Then users collect the data from the device typically on a daily basis. Then users perform the manual analysis of data using statistical tools. Based on the analysis, the prediction is generated and then prediction report is generated with a proposed schedule of maintenance. Insights from our task analysis are, you can see that there are many tasks which are performed manually, such as data collection, analysis of data, prediction generation, and prediction reporting. Out of these, the data collection and prediction reporting can be automated, and data analysis and prediction generation can be handled by our ML model. Our ML model is a hybrid model with a simpler model running on the device for the local predictions and a cloud-based model for predictive maintenance. Cloud-based solution will pull the data from the device periodically and then generate predictions using our trained model. The prediction reports are delivered to the users through emails to meet the constraints of periodic predictions. It is important to design the user experience as many of the steps are being automated and many other are taken over by our ML model. The user interacts with the system through a standard form for configuring various system parameters, such as configuring the sensor or measurement points, configuring the trigger points for the local monitoring, configuring the data retrieval schedules for the cloud data collection, configuring the user details such as email addresses of recipients for the prediction data reporting. Other interactions is provided to have a manual review of the predictions with low value of output metric, that is human in loop. Experts can have a look at low confidence predictions before reporting them to users. AI specific considerations for the user experience design are user inputs, transparency, communicating uncertainty, and the feedback loops. User inputs, as stated earlier, is through a single form where user configures the system. Interaction to the systems are kept at minimum. And ease of use with the features such as copying the configurations to other motors. Transparency is provided through the prediction reports, which lists out the analysis performed with a graphical representation of features and outputs. These are similar to the ones user is familiar with the manual method and can easily relate to. This clearly explains the parameters based on which the prediction is arrived. We have an advantage here with the manual process that existed earlier and can compare the output of the model. In case the model's confidence level is low, that there is uncertainty, the expert advice is requested with a full analysis data provided to expert. When expert user makes the decision, also the predictions are provided the confidence level so that end user can make an informed decision. There is an explicit feedback loop where user enters the details of motor maintenance, including the actual date of maintenance, the type of maintenance, which are used to monitor the model performance and retraining decisions. As our system collects the personally identifiable information and other critical asset related information, we need to follow the fair information practices. Currently planned operations are only restricted in US and EU GDPR is not applicable. As a part of fair information practices, users are provided with the privacy policy notices and explicit consent is sought for the data storage. Information security policies are implemented and audited to protect the user data. The system access is restricted to authorized users and information of only active user is stored. The user have a choice of updating their information and opt out if required. Ethical considerations are low due to the nature of the project and predictions are for the motors and they affect the overall industrial plant performance and not directly a human. However, there could be a bias which may lead to suboptimal performance and not meeting the outcome desired. Due to the nature of existing manual system and experience of using it for a long time, there is a less chance of historical, representational or measurement bias. The manual system has detected many of them in the past and corrected. However, there is a higher chance of learning bias as the data for the same type of motors from a different locations, applications may vary due to other environmental issues such as installation, other heavy machinery around, etc. Our product will meet the goals of ethical AI, that is fairness, accountability, and transparency in the following ways. Let us consider the fairness. As stated earlier, there is a higher chance of learning bias as the data for the same type of motors from a different location, applications may vary due to other environmental issues such as installation, other heavy machinery around, etc., which can be addressed by maintaining the data sheets for the dataset, using enough environmental information covered, and through the user feedback. The next point is accountability. The system provides the predictions with a confidence level, and wherever it is not able to achieve the satisfactory confidence level, expert user intervention is sought. Thus, user is in control. Transparency is provided through the prediction reports, which lists out the analysis performed with a graphical representation, which is similar to the one user is familiar with the manual methods and can easily relate to. This clearly explains the parameters based on which the prediction is arrived. We have an advantage here with the manual process that existed earlier and can compare the output of the model. That brings us to end of this presentation. Thank you for your time.